Welcome back. Problem 11-2. So statement is determine the minimum width of the beam to the nearest 1/4 inch that will safely support the loading of 8 kips. The allowable bending stress is 24 ksi and allowable shearing stress is 15 ksi. So load is 8 kips. The height of this beam is 6 inch. Allowable stress is 24 and allowable shearing stress is 15 ksi. Minimum width of the beam is to be find. Now you can see this figure, the beam that is acted upon by a load P at this end, while at point A there is a roller support and at point B there is a pin support. The total length of the beam is 12 feet. Clear? So the first step is to find out the reaction forces if we remove this support. So there will be a reaction force which is represented as Ra, and if we remove it there will be a reaction force which will be Rb, and that will be acting downward. Now you can see this load is acting downward, so this force will be upward while this force will be downward. You can take any force, and when you apply the equilibrium condition you will get the exact value. So let's start with the first. So first equilibrium condition is sum of all moments about point A is equal to 0 and taking the counterclockwise movement as positive. Now movement about point A is due to this load, which is P into perpendicular distance is 6 feet, and this is counterclockwise, so it will be positive. And P is given as 8. So 8 multiplied by 6, and the second movement which is due to this RB and perpendicular distance is again 6 feet, so it will be counterclockwise. So that is clockwise, that will be negative. So minus RB into 6 is equal to 0. So it means that 6RB is equal to 48. And from here you will get RB is equal to 8 kips. Since the value is positive, so it means that our assumed direction, which was downward, is correct. Now we know that sum of all forces along y direction must be equal to 0 and taking the upward force as positive. So three forces, one is P that is acting downward, the other one is RA which is acting upward, this one, and this third one is downward, which is minus 8. Their sum must be equal to 0. So it means that RA is equal to plus P plus 8. P is 8 plus 8 is equal to 16 kips. Okay, so from here we get RA is equal to 16 kips. Now what we will do is that we have to find the minimum width of the beam. So let this beam is rectangular in cross section. See, what if I draw the beam just like this? So this is its minimum width B, and this is height H, which is equal to 6 inch there, and the neutral axis will be at the mid. So this distance will be equal to C, and that will be equal to 3 inch because H by 2 will be C. Now we know that allowable stress is equal to maximum bending moment into C divided by I. So for that we do not know the maximum bending moment. So what we will do, we will draw the shear force and bending moment diagram in order to get this. So for that I have to draw the beam. So this is the total beam. Clear? At point this we have a load of 8 kip. Clear? And since let this is the mid, so at mid we have RA which is 16 kips, and at this end we have 8 kips. So what if I draw the shear force and bending moment diagram? So let's draw it. So along x-axis we will take the length. This here we will draw the shear force, and that will be in kips. Okay, and each division is, let's say, 4. So 4 plus 4, this is 8, since minus 4 and minus 8. Now you can see at this point, we have a load of 8 kips, and that is downward, so it will be minus 8. So at this point we will have minus 8. So this will be the first point. Now from 8 minus 8 till this, we do not have any other shear force, so shear force will remain same till the midpoint. So I will draw it. Shear force will be this one till this point. Now at this point you can see there is a load of 16 kips, and this is minus 8. So minus 8 plus 16 will be plus 8. So our new point will be this one. So at this point shear force will change from minus 8 to plus 8. Now from this section to this, there is no shear force there, so it will remain the same. So it will remain same till this point. And you can see that at this point we have 8 kips downward. So this is plus 8 and this is minus 8. So it will bring down to 0. So this is your shear force diagram. Now from shear force diagram we will draw the bending moment diagram, and this bending moment is equal to, will be in kips into feet, because the length is in feet. So from this to this distance is 6 feet. Let me draw it correctly. This is 6 feet. And this is also 6 feet. Now the area under the shear force diagram will give you the bending moment. Since this is rectangular, so area will be equal to base into height. So base is 6 feet and height is 8. So 8 6 minus 48. So at point, initially at point x is equal to 0, moment will be 0. And at this point, at the mid of the beam, this will be 8. I will show you again. This is its height, which is minus 8 multiplied by length 6. So 8 6 48. And since you can see that the load is this shear area is negative, so its slope will be downward. Okay, and the also the shear force line is a 0 degree straight constant line. So first moment equation will be the first degree higher, and it will be, let each point is of 10 10 40 will be here and 50 will be here. Let assume that each division is of 10 kips into feet. So your minus 48 will be kips into feet will be somewhat here. So I will join them. This slope will be decreasing because it is negative, and it will be straight line. Now this is minus 48. Okay, let's proceed further. You can see the second area is this one, and this one is also plus 48. So minus 48 plus 48 will bring it to 0. So at this point again it will be 0. So this will be your bending moment. You have to join with this point. There is some problem that is not picking this point. So you have to take it to the nearest 0. Okay, so assume this is equal 0. Now from here you will get that maximum bending moment is mod of maximum bending moment is 48 kips into feet, and in term of inch it will be equal to 48 multiplied by 12 kips into inch. So we know that allowable stress is this one. What will be the I? So I, we know that for rectangular beam it is equal to 1 over 12 BH cube. So B, we do not know B, we have H is 6, so 6 cube. Clear? We have C that is given over here 3 inch. So you can put the value, you will get sigma allowable is equal to 48 multiplied by 12 multiplied by C, which is 3 divided by I, which is 1 over 12 B into 6 cube. And sigma allowable value is also given in the question, that is 24 ksi. So you can just put it 24 in ksi. Okay, 24 ksi. So 24 into 48 multiplied by 12 multiplied by 3 divided by 1 over 12 B into 6 cube. So when you solve it, you will get B is equal to 4 inch. So this is the minimum width of the beam. Now how you will ensure? So for that you have to check the shear. Check shear. As we know that maximum shearing stress is equal to V into Q divided by I into thickness T. Here in term thickness is B. So you can see that V is again 8. Maximum value of V is 8. Okay, so 8. What is Q? Q is equal to Y dash bar into A dash. Now A dash is this one. Clear? And Y dash will be this one. This will be Y dash bar, and that will be equal to 3 divided by 2 is equal to 1.5. And this area is 3 multiplied by this width 4, this shaded area. Okay, so I will write it direct over here. Y dash is 3 1.5. 3 divided by 2. We'll write 3 divided by 2 into area was 3 into 4. Divided by I is given as, if you put the value of I, B over here, so you will get 1 over 12. B is again 4 into 6 cube into 4. So from here you will get maximum shearing stress comes out to be 0.5 ksi. Now this tau max is, again you can see, less than tau allowable, and tau allowable is 15 ksi. So it means that the height of the beam is 6 inch, while width is 4 inch for the given loading only. I hope you have enjoyed this video. I will suggest you to go to the problem 11-3 and solve it by taking P is equal to 10 kips, and tell me your answer in the comment section. Again, if you have any question, you can ask me in comment section as well. And those who are new to my channel, then subscribe it and keep watching. Thank you.